Hello. So I'm Estefania. That's how you pronounce my name, Estefania. And today I'm going to be talking about reactive programming in Node.js. Does anybody know what reactive programming is? Okay, a few hands. I thought everybody was going to know this, so it's good. I'm going to talk about something that not a lot of people are familiar with. So about me, it's kind of weird for me to be standing here in Amsterdam giving a talk about software engineering, since 3 years ago I thought I was going to be a sociologist. I love sociology, I still do love it, but 2 years into my major, I realized that I was learning more online than what I was doing at school. And school is expensive, so I got mad and I decided to drop out. So yeah, I was like, okay, what can I do without a degree? And I heard people code without degrees, so I gave it a try. And I really fell in love with it. It's like I feel like I was born to do this. I really like it. So yeah, I learned to code, and then I joined Accenture, and I am now a senior software developer at Accenture. But if you are Mexican, it's not really a good thing to not have a degree. It's kind of an obstacle. So I went back to school, and I am now studying computer science. And in the meantime, I'm also working. So that is Monterrey. That is where I'm based at, and that's where I'm from. It's in the north of Mexico, northeast, and it's right beneath Texas. And those are my two babies. That's Duque and Madonna, and I miss them a lot. This is also my first time speaking at a tech conference, and I wanted to thank the organizers for having me here and trusting me. Like, I've never done this, so that's nice. Thank you. Oh, and thank you, all of you, for being here. This is my favorite meme because I relate to it. So I started working at Accenture, and I could talk about React and Angular and Node.js, and I was just like, yeah, I'm a full-stack developer. But since I joined Accenture, I've been working in pretty back-end heavy applications. So like, I just lost track of what was going on the front end. Like, I just don't know what's happening. So I should get back to it and see what's going on there, but I like Node.js a lot, so okay. First disclaimer, English is not my first language. So if I invent some words, or if my grammar is like bad, I'm sorry, but I'm going to try to be as clear as I can. Second disclaimer, I am nowhere near an expert to reactive programming. I just started learning this like a few months ago, and I do not use this professionally, but I am going to share with you what I have learned in these few months. And I did not add a third disclaimer, but I'm going to mention it. I have 0 design skills, so this is like as good as it gets. Okay, so I'll begin by explaining. Okay, so I'm going to begin by explaining reactive programming as a paradigm in general. If we go to Wikipedia, we get this definition. In computing, reactive programming is a declarative programming paradigm concerned with data streams and the propagation of change. With this paradigm, it is possible to express static example arrays or dynamic example event emitters data streams with ease, and also communicate that an infer dependency within the associated execution model exists, which facilitates the automatic propagation of the change data flow. Yeah, so I don't know if it's the fact that English is not my first language and that this definition has a lot of big words, but like, I read this and I got anxiety. Like, I had no idea what I was talking about, and I read it all over, like, along a lot of times. So to understand it better, I decided to dissect the definition and go step by step. So that worked for me. It might work for you if you didn't get it as I did. So first, it tells us that it's a declarative programming paradigm, which means that we are telling the program what to do instead of how to do it like we do in imperative programming. So in here we see like it's just doing some instructions, and in declarative programming we just say like reduce, and suddenly the value gets reduced to a single value. But I noticed something on the Wikipedia page. If you go to the list of programming paradigms over there, you see that reactive is a child of declarative, but it's not a first child of it. So it is a first child of data flow. So to get a little bit of more insight, let's find out what data flow programming is. So data flow programming is a programming paradigm that is more concerned about the data being processed than the actual code. It works by modeling a system as directed graph of data flowing between operations, which we can call nodes. So you have a stream of data, which is passed from node to node of the directive graph, where each node is an operation being done to the data. We have conditional execution, if statements, that is telling the data to what node it should be going next. The flow is one way, in the sense that once a piece of data reaches the end of the node, the process is completed, and you can restart it with more data, and it's going to be OK, but the data cannot go upward. And in this paradigm, you're most concerned about the input and output of the data. It's like the most relevant information. So there's something else that the definition mentions that is also very important. That is, and also communicate that an inferred dependency within the associated execution model exists to propagate the data flow. Later on, when we see a library that implements the reactive programming paradigm, we will be able to see this propagation of changes to dependencies can be achieved by using the observer pattern. So the observer pattern is just a design pattern in which an object called the subject maintains a list of its dependents called observers, and notifies them automatically of any state changes. We use this all the time when we add event listeners to events, and a lot of people ask, isn't reactive programming just the observer pattern? And the answer is no. This is like the next level of the observer pattern. Instead of having a callback or a listener reacting to these events, we subscribe to them and add all of this data flow routine filled with conditionals and different operations. So it just like, instead of just doing one function, it does a whole lot of things. To illustrate this, I'm going to use a marble diagram. I am a very visual person, so the fact that everywhere where there's talk about reactive programming, there's also marble diagrams, is very useful for me. So this is what a marble diagram looks like. The horizontal line represents time. The circles are the events generated by the stream. The blue boxes are the operations being done on the stream. The circles below it are the result of such operations. And the dotted rectangle represents what would be a data flow routine. And it is important to note that in the library I'll be using later, on all of the streams that there are, like stream A, stream of B, stream of AB, and stream of results, they are all different observables. And yeah, so they are original. Every time like there's an output observable, it's a new observable. It's not like the one modified. So it's cool that some functional programming principles are being used, and we get like pure data. So here, if we look at the dotted line, which represents a data flow routine, we can see how the data is being passed from operation to operation until we reach the green circle, which is the end in this case. So what is interesting is that these chunks of data that we're working with could be items of an array, they could be variables, they could be object properties, or even HTTP responses being treated as data streams. And this data flow routine could be get triggered every time there's a change or we receive an input. This is why this paradigm is called reactive programming, because we are observing that data and we are reacting when there is something new. So now that I've abstracted the definition, I hope you're not looking at me as if I were like this. So now, let's get reactive. These are some of the reactive programming libraries that we can find in JavaScript. There's more than this, but these are the most popular ones. So that's RxJS, that's MobX, Bacon.js, and Highland. But for this talk, I decided to use the JavaScript version library of the ReactiveX family, since ReactiveX is the most popular reactive programming library using JavaScript. And it is very easy to create event or data streams, which can be composed or transformed with a variety of different query-like operators. You can subscribe to any observable to perform side effects, where each subscription is isolated and does not depend on any subscription to the same observable. So you have an observable, and then you can subscribe to it here and do a bunch of operations, and you can subscribe to it again and do more operations. And these two subscriptions, they're isolated, so they will not be affecting each other. And what's cool about it is that there's this same library is available in all of those different languages. So you just learn one API and you can use it in different languages. So I find that pretty cool. OK, observables. Observables are lazy push collections of multiple values. They are streams of events that we can subscribe to and perform operations to. For the pool system, we have functions for one value and iterators for multiple values. And for the push system, we have promises. That's for one value. And now we have well, not now. This is not new. But we have also observables that are like the iterators for the push system. So what is push and pull system? So here, what push and pull mean is that there are publishers and consumers in all four of these. In the pull system, the consumer decides when to get the data, and in the push system, the producer decides when the consumer gets the data. So that's like the difference between them. So this is one way of creating an observable in RxJS. We create a new instance, and we pass in the subscriber. And then the subscriber will be like the return value of a function. So it's like if we have a function, and every time we call the next, it's like if we were returning a value from it. So we can return multiple times. And when we're done, we will just call complete. But since this is a lazy operation, that the top part of the code will not get called unless we subscribe to it. So once we subscribe to it, we have the next function, the error function, and the complete function. And the next function will get called every time there's a value being emitted from the observable. So here we will have like the console log just before subscribe. Then we will have 1, 2, 3. We'll wait for a second, and then 4. And then complete, since we are calling complete over there. And to these observables, we can add some stuff in RxJS that are called operators, which is like what people like the most about this library, which is like the ability to transform all of these streams of data, like add the operations to them. So we have two types of operators. We have the creation and the pipeable. Creation is to create a new observable, so like this, but we can also create them with the off from event and range and empty of the API. And the pipeable ones are like pure functions that take one observable as an input and create another observable as an output with that operations being done to them. So this is what the creation, some of the creation operators look like. So we have the from one, which it means that we are creating an observable from an array. So every item on an array will be treated as an event on the stream. And we will get like 10, 29, 18, 20, and the line means it's completed. And for interval, we will have a sequence of integers that will be incrementing every 10 milliseconds. So that one it runs from 0 to infinite time. So we have to close it sometime. If not, it's going to run forever. We have an operator that's really powerful, that it's merge. So in there we have two observables, the top ones on the top of merge. And when we apply this operation to them, we get them like in one single operator with all of the events at the time they happened. So when we create the observable here, and then we create another observable that is the range one, which is like we create a stream with 1, 2, 3, 4 events, and then we merge them, we get that as an output. So we have the before subscribe, then 1, 2, 3, and then we get the range. It's 1, 2, 3, 4, and then 4 since the timeout was set to happen afterwards. And we have another one. Oh, sorry, that's concat. Yeah, this is kind of similar, but it is not the same. So we have the same code, but instead of merging them, we're doing a concat. And instead of putting them at the time that they happened, it first takes the first event the first observable that it got, and adds it first. And when that one is done streaming events, it will add the other observable. So yeah, we have like 1, 2, 3, 4, even though we had the timeout, and then again 1, 2, 3, 4 of the range of the other observable, and then complete. In the throttle time, it will just allow one event every 500 milliseconds in the code. Sorry that I did not match them. I did not think about that, but yeah. So in the marble diagram, every 250 milliseconds, it will grab the first event that it sees, but it will not grab any other event that it's going through, we're getting, until the 250 milliseconds happens. And then with the take operator, we're just going to grab 2 of those. So if we keep getting more events, we're going to ignore them. So yeah, that's an interval. So that type of observable goes forever, but we stop it by using the take 10. So it will just grab the intervals that are in the 500 allowed time span, and then it will just take 10 of them, and then it will complete, and it will close the observables, the streams. And the race it will only grab the first observable that streams the first event. So yeah, we have the fast one, which is the blue one, and then the medium one, which is the red one, and the slow one, which is the yellow one. And only the blue one is going through because it's always the first. It was the first one to emit an event. So what can we do with it? Reactive programming is really popular on the front end because you can do a lot of very powerful operations in them. So you can do a drag and drop, and you can do like a search input and just be updating like that and doing games and stuff. But yeah, here I compare an imperative way of doing something and the reactive way. So in this one, I just want to in both, I just want to grab. I have IDs of users, and I want to grab the data of that users and their favorite movie. So in the imperative way, it's kind of really hard to read what it's trying to do. Like you have to go step by step and read it more carefully, and then to understand it. And in the reactive way, I can just go like, I have the user ID observable, then I map it and get the user and movies for that ID, and then I concat it all because I have 2 observables, and I put them together, and then I filter if they're authorized. So it's like a really easy way to read it instead of having like all of this. it helps developers code faster, and when you get a hang of it, it's easier to read the data. It's easier to read the code. So it's like saves you time in developing and in doing peer reviews and stuff. So I find it pretty cool. So what about Node.js? So reactive programming with Rx.js on the back end is pretty much written the same way in the front end. In the back end, of course, we're not observing like document events. We're mostly observing HTTP responses or events emitted from the event emitter, or we can have messages coming through from some message protocol. And Rx.js has some different APIs for Node. There are just like two different operators, which are the bind node callback, which just transforms a common node callback like the error first and then the result, and it converts it to an observable. And yeah, we create events from the event emitter with the from event operator. So a very famous use case for this is when Netflix redesigned their server to be reactive. So they're really big into this reactive stuff, and they have a lot of talks about it. And so they really are very active in the reactive programming community. So this is how it was before. They had like a bunch of network requests going to their servers, and they were the server responses looked like that. And since they had a very generic backend, and they were using for different clients, and they were just grabbing what they needed from the backend, they were starting to get like a whole load of requests. So with the increment of users, this got out of hand, and because each client needed to make multiple requests for a single page of the application, the network latency got like overloaded. So they had to change it to something like this. They moved all the logic required to create a data set to the backend using reactive nested conditional and parallel execution, which this nested conditional and parallel execution is something that is facilitated by the reactive approach. So they also mentioned that they realized that it made it easier for developers to handle concurrency, and the code is readable, and getting the data from the server sources at the same time is just a matter of subscribing to it. So in my personal opinion, like at the work I do at my job, I do see the benefit of reactive programming. So as I mentioned, I do not use it at my job, but the project I'm working on right now, it's a metadata distribution platform, and its own architecture is distributed between workers, and they talk to each other using RabbitMQ, which is a message broker software, and we receive a lot of data which goes through extensive transformation process, and it is sent to different microservices. So these transformation processes are queued by RabbitMQ, and the whole system is already kind of a push system. There is a scheduler publisher, there is RabbitMQ that is telling the consumer when to consume the data. And then we get a lot of data from some source which goes through a routine of operations, just like a data flow routine. And the system itself is kind of already reactive. It is just not following the paradigm. So I believe that if I were to do it again, which I'm not going to, but if I were to do it again, using the reactive programming approach would make it like way more easier and more like in touch with what it's already doing. So it would be like way more readable, and I think it would be way faster. So this would also work like if you had an application that is using Kafka. Since it is something that is already event driven, reacting to events is like, it seems more natural. So yeah. So what are the pros and cons of reactive programming? So the pros is that error handling is very easy. It's like you just have the error function in the subscriber that catches the errors. And the code is easier to read and understand. It pushes to be written in a more functional way, which promotes clean inputs and outputs, and it's like you don't have a lot of dangerous side effects. You can treat everything as the same type of thing, making data easier to handle. So everything in reactive programming will be transformed to a stream. So you can just like put them together and do operations with them. It doesn't matter if it was an HTTP response or an array. You can make them be the same thing. So that's like really, really powerful because the operators work for streams. So I think that's cool. And they remove the limitation of a promise that they can only handle a single value, like the single response. And it allows you to handle multiple values from like the same observable. It simplifies concurrency. And it is a powerful API for transforming data, which I find is like the funnest part, just chaining operations and transforming everything. And observables are cancelable, which promises aren't. I think in JavaScript they aren't. The cons are that it takes time to learn it. Like to think reactively it's a whole process, and you have to change how you think. And the RxJS library recently went through a complete change in their API, which messed a lot of people's code, so they had to change it. So if you see tutorials right now, they are mostly outdated, and that can be a little bit confusing. But they say they're going to keep it how it is right now, so I think that's OK. Oh, and it could also be overkill to implement in some cases, like when you're just handling single events. Why would you want an observable if you're just going to use it once? So yeah, I mean, I really enjoyed learning about reactive programming. I find it very fun and powerful. But as everything in programming, I think that it has its use cases. I don't believe it is necessarily better than any other paradigm. But there are some programs that would benefit more by using reactive programming, and there are some programs that maybe won't. So yeah, I hope you enjoyed it, and thank you very much for listening.